So in the last class, we did talk about the piezoelectric effect. And we saw that if we can somehow manage to apply an alternating voltage whose frequency lies in the ultrasonic range, we can generate ultrasonic waves using inverse piezoelectric effect. Now the question comes, how do we do that? So we said that I can have a piezoelectric crystal basically. And in that piezoelectric crystal, if I can somehow manage to apply an alternating voltage, conditionally the frequency of this voltage is greater than 20 kilohertz, then this crystal will start changing its dimension with the same frequency here. And you can generate ultrasonic waves of the similar frequency. Now the question comes, how do we produce an alternating voltage of this frequency? Here, what you can do is that, as we discussed in the last class, our most obvious choice is an LC circuit. LC circuit की frequency we know that is given by nu is equal to, just a second. शिवानी और कुंदन बार बार ना स्टूडेंट्स आ रहे हैं, वो वेटिंग रूम पे एग्जैक्टली जहां पे मैं लिख रही हूँ वहीं पे वो ब्लिंक किए जा रहा है. आप प्लीज उनको जरा जल्दी लेट इन कर दीजिए.
Yes, ma'am. I'm trying. Yes, ma'am.
So this is the frequency of an LC circuit, right? So I can control the frequency of the current and voltage by changing the value of the capacitance. Variable capacitor are easily available in the market here. So how can I do that? The simple procedure would be that I have an inductor, I have a capacitor here. Let's say this inductor has inductance L1, this capacitor has the value C1, then this would be L1 C1 here. Now, if I can place another coil here and connect it to two metallic plates, उस metallic plate के बीच में, if we can manage to place a quartz crystal here, what would happen in this case? Let's first stop here itself. We'll see why we can't do this simple procedure. You have an LC circuit here, right? Let's say your capacitor is fully charged. Even in that case, what would happen here is in this LC circuit, there will be oscillatory current and there will be oscillatory voltages also in this L1 C1 current here. अगर आपका current time varying होगा in L1, then this L1 will be inductively coupled with L3, right? अब L3 में क्या होगा? आपकी induced EMF होगी. Induced EMF होगी because you will have a time varying magnetic field. You will have a time varying magnetic flux because you are having a time varying current flowing through this coil L1 here. आपके L1 कॉइल के थ्रू एक टाइम वेरिंग जो करंट है वो फ्लो कर रहा है, उसकी वजह से आपका एक टाइम वेरिंग मैग्नेटिक फील्ड प्रोड्यूस होगा, दैट वुड लीड टू ए टाइम वेरिंग मैग्नेटिक फ्लक्स, जिसकी वजह से यहाँ पे इंड्यूस्ड ईएमएफ प्रोड्यूस होगी. अब ये इंड्यूस्ड ईएमएफ है, दिस इंड्यूस्ड ईएमएफ विल हैव द सेम फ्रीक्वेंसी एज इज द फ्रीक्वेंसी ऑफ दिस L1 C1 सर्किट. इंड्यूस्ड ईएमएफ की जो इस आपके L1 C1 सर्किट की फ्रीक्वेंसी है, एग्जैक्टली सिमिलर फ्रीक्वेंसी होगी. अगर इंड्यूस्ड ईएमएफ इसमें फ्लो होगा, इंड्यूस्ड ईएमएफ इसमें जनरेट होगा, तो इस दिस पार्ट ऑफ द सर्किट व्हिच इज कॉल्ड एज द सेकेंडरी सर्किट. In the secondary circuit, what would happen? Current will start to flow. अब इसमें जो करंट फ्लो करेगा वो करंट भी आपका टाइम वेरिंग करंट होगा, which will have the same frequency as is the frequency of induced EMF. Because of which what would happen? एक बार यहाँ पे जो प्लेट है उस पे पॉजिटिव आएगा, एक बार इस पे नेगेटिव आएगा. नेक्स्ट टाइम उस साइकिल में अगर आपका करंट ऐसे आ रहा है तो लेट्स से फर्स्ट टाइम यहाँ पे पॉजिटिव आया, यहाँ पे नेगेटिव आया, जब आपकी साइकिल रिवर्स होगी तो यहाँ पे आपका नेगेटिव आ जाएगा, यहाँ पे आपका पॉजिटिव आ जाएगा. So now you are applying a voltage on it which is a time varying voltage, and by changing the value of this capacitor C1, I can make this frequency in the ultrasonic range, right? But here is the problem. This L1C1 circuit is not an ideal L1C1 circuit, right? अगर आप इसकी practicality की बात करें, there are going to be some losses in this circuit. We need to compensate for those losses, right? ये basically, let me repeat that, this is not an ideal LC circuit. You will have certain resistances, and you know what happens in the LCR circuit from SHM. आपका charge और current है वो with time decay out कर जाएगा. In the case of, let's say, underdamped oscillation. So we need to come up with some method of feedback in such a way that whatever energy is lost, we compensate for that energy only. So we need to have a feedback system for this. And that feedback should be in such a way that जब कभी भी इसमें current fall करना start करे, वो उस current को वापस उसकी initial value पे ले आए. How that is done? That is done using a transistor here. यहाँ पे हम एक transistor use करते हैं. And there is another inductor coil which is connected over here, and this is connected to a battery here. This battery is basically, you know, for operating a transistor, you need certain voltages, 5 volt, 7 volt, 10 volt, जितने भी आपको voltage चाहिए है. And this transistor is basically an NPN transistor. So you will have current flowing from here to here. This is going to be your emitter, this is going to be your base, and this is going to be your collector. You know that your emitter current is sum of base current plus collector current here. So now what would happen in this case? यहाँ से जब कभी भी, now not only this L1 and L3 are inductively coupled. This L1, if I call the second coil as L2, L1 and L2, they are also inductively coupled with each other. So what would happen? Every time there is a change in the current here, there will be an induced EMF produced here also. And that induced EMF will have some current flowing in this part of the circuit, and which will be fed back into your this part of the circuit, which is tank circuit or LC circuit here. So this part of the circuit is simply a feedback circuit. Which basically keeps the amplitude. Remember, LCR circuit mein your charge was, for underdamped oscillation, your charge was something Q max e raised to power minus r upon 2l t cosine of omega dt plus phi, right? So your amplitude is going to decay exponentially. By applying or by having this feedback circuit, what you are trying to do is you are trying to get rid of this term here, so that your amplitude, which is Q max or which is going to be I max, it remains the same here. And that purpose is served by this part of the circuit, which acts as a feedback circuit. जैसे ही आपका यहाँ पे amplitude कम होना start करेगा, यहाँ पे induced EMF उसको oppose करने का try करेगा, right? And यहाँ पे आपका current जो है वो बढ़ जाएगा. जैसे ही यहाँ पे आप अगर amplitude, anyway amplitude is not going to increase because there are going to be only losses in this case. So this is how this circuit is going to work now. You have a tank circuit. ये आपका tank circuit है. The frequency of the tank circuit is given by this number here. If you make the frequency of this tank circuit equal to the natural frequency of the quartz crystal, which is given by this number here, where E is the modulus of elasticity of quartz crystal, rho is the density, and L is the length or the thickness of the crystal here. So you will have a time varying current whose frequency will be given by this number over here. Similar frequency induced EMF will be produced in L3. Induced EMF होगी वो सेम फ्रीक्वेंसी के साथ में होगी. दैट मीन्स यहाँ पे जो आपने दो मेटालिक प्लेट के बीच में क्वार्ट्ज क्रिस्टल को रखा है, वहां पे आपके ऑल्टरनेटिंग चार्जेस जो हैं वो अक्यूमुलेट होते चले जाएंगे, which basically means that you are placing the quartz crystal in an alternating electric field whose frequency is greater than 20 kilohertz. क्वार्ट्ज क्रिस्टल की डायमेंशन चेंज होंगी तो उसके पास में जो आपकी एयर के मॉलिक्यूल्स हैं वो भी सेम फ्रीक्वेंसी के साथ में वाइब्रेट होना स्टार्ट हो जाएंगे एंड दैट वुड एंड अप इन द जनरेशन ऑफ अल्ट्रासोनिक वेव्स. So this is the method for generation of ultrasonic waves. Anyone has any doubt in this
Ma'am,
part
can
of
you
the
please
circuit?
explain this feedback circuit, why we need it?
Because this LC circuit, if I don't have the feedback circuit, this LC circuit is not an ideal LC circuit. Right? आप एक इंडक्टर और कैपेसिटर को कनेक्ट करोगे. Let's say that you are using some wires to connect them. They will have some finite resistances in that case. So this will be basically an LCR circuit. And from our study in SHM, we know that अगर आपका LCR circuit होगा तो आपका amplitude है वो time के साथ में decay करता चला जाएगा. So what would happen in that case कि आपकी amplitude decay होगा. That means amplitude is directly proportional to intensity is amplitude square. राइट तो आपकी इंटेंसिटी अल्ट्रासोनिक वेव्स की इनिशियली तो लार्ज होगी बट जैसे जैसे यहाँ पे आपका चार्ज और करंट डाई आउट करना स्टार्ट कर देगा आपकी इंटेंसिटी अल्ट्रासोनिक वेव्स की डाई आउट करनी स्टार्ट कर देगी. So you need to come up with the method in such a way that whatever energy is being lost from this LC circuit, you feed back that much energy into the circuit. And that is basically done by this feedback circuit here.
Ma'am, and how this transistor is helping us to put that energy back into the system?
Because at the end of the day you have the emitter current which is sum of the base current and collector current, right? So जैसे ही आपका let's say base current यहाँ पे reduce होना start होगा यहाँ पे आपका जो induced EMF होगा वो उसको oppose करेगा तो आपका collector current है वो increase होना start हो जाएगा और जैसे ही आपका base current बढ़ना start होगा वैसे ही यहाँ पे आपकी induced EMF फिर से oppose करेगी आपका collector current है वो कम होना start हो जाएगा. Base is basically kind of tap में अगर आप कितना पानी flow करेगा you can attach that with the base. Base decide करेगा कि collector to emitter कितना आपका current flow करेगा. So that's how this feedback circuit helps you in keeping the constant amplitude of current and charge in LC circuit. Okay, so if you follow N.K. Verma book or Khanna and Bedi, initially transistors were not there. In place of transistor, triode valves used to be there. Triode valve and transistor are basically an advanced version of triode valve. Much bulkier hoti thi, deal karne mein difficult hota tha. So what used to be in the triode valve? Triode valve mein kya hota tha ki aapke paas mein ek cathode hota tha, जिसको कि आप हीट अप करते थे हीटर लगा के यहाँ पे एक ग्रिड होती थी और यहाँ पे आपकी एक प्लेट होती थी एंड इन बिटवीन ग्रिड होती थी. सो ये कैथोड जो होता था ये आपका इलेक्ट्रॉन एमिट करता था. यहाँ हीटर से आप इसको हीट अप करते थे यहाँ से इलेक्ट्रॉन एमिट होते थे एंड लेट्स से यहाँ से जो इलेक्ट्रॉन एमिट होते थे हाउ मेनी ऑफ दीज इलेक्ट्रॉन्स विल रीच द प्लेट दैट वुड बी डिसाइडेड बाय ग्रिड, राइट? अगर आपका ग्रिड पे पोटेंशियल जो है नेगेटिव पोटेंशियल ज्यादा है तो इलेक्ट्रॉन रिपेल होकर वापस आने स्टार्ट हो जाएंगे और अगर आपका ग्रिड पे पोटेंशियल कम है तो आपके ज्यादा इलेक्ट्रॉन है कैथोड से प्लेट में चले जाएंगे. So in that scenario, grid is nowadays in transistor is basically your base. Cathode is emitter. Cathode emits electron and so does emitter. Plate जहां पे आप electrons को collect करते हैं, that would be your collector now. So अगर आप खन्ना एंड बेदी या एनके वर्मा फॉलो कर रहे हैं तो यहाँ पे ये ट्रांजिस्टर की जगह you will see a triode valve and triode valve is nothing. जहाँ पे आपका कलेक्टर है वो एक प्लेट होगी मेटालिक प्लेट जो इलेक्ट्रॉन्स को कलेक्ट करेगी. बेस है वो एक ग्रिड होगी जो डिसाइड करेगी कि एमीटर में से कितने इलेक्ट्रॉन है वो कलेक्टर तक पहुंचेंगे और कैथोड है which is used for emission of electrons by heating up of cathode is now basically your emitter in the transistor. Just for your reference, if you are following N.K. Verma or Khanna or Bedi. So if you are asked principle, construction and working of a piezoelectric oscillator, you need to tell the principle that it works on inverse piezoelectric effect. You need to tell what is inverse piezoelectric effect. Then you need to talk about the construction, that there is an LC circuit or the tank circuit, there is a transistor here, and then there is a second inductor coil, there is a third inductor coil, and your quartz crystal is placed between two metallic plates. And this is a battery which is basically used for providing bias or voltage to the transistor. Working में you need to explain, यहाँ पे आपका LC circuit है, LC circuit की this will be the frequency. When this frequency matches with the natural frequency of the quartz crystal, resonance will happen in that case. You need to explain L1 and L3 are inductively coupled. अगर आपका L1 में टाइम वेरिंग करंट होगा, L3 में टाइम वेरिंग इंड्यूस्ड ईएमएफ होगा, तो इसके ऊपर आपके पास एक टाइम वेरिंग पोटेंशियल आप अप्लाई करोगे. And this part of the circuit is the feedback circuit. Now, if you talk about what are the plus points and the minus point of this circuit, what are the advantages and disadvantages of a piezoelectric oscillator? Because we are doing two oscillators, so we'll compare both of the oscillators. So if you talk about the advantages here, the first advantage is you can produce the high frequency ultrasonic waves. Up to 500 megahertz. आप इतनी हाई फ्रीक्वेंसी की अल्ट्रासोनिक वेव्स जो हैं वो इसको यूज करके प्रोड्यूस करा सकते हैं. देयर विल बी नो इफेक्ट ऑफ ह्यूमिडिटी और टेम्परेचर. These are the advantages of it. We'll talk about magnetostriction. जो ferromagnetic material में होता है वहां पे आपकी humidity और temperature जो है वो significant role play करना start कर देते हैं. So these are two major advantages of using an piezoelectric oscillator. If you talk about the disadvantages, there are two things. One is intensity. Second is the frequency, right? You can have very large frequency, you can have very large intensity also. Intensity means how many number of ultrasonic waves you are producing. Frequency is what is the frequency of those ultrasonic waves. So disadvantages of piezoelectric oscillators is that you will have low power or low intensity ultrasonic waves. The second disadvantage will be this piezoelectric quartz crystal is quite expensive. The third is, when I talked about the piezoelectric effect, I said there are certain crystals. So if you, even if you take any regular quartz crystal, it will not show any piezoelectric effect. You need to cut it along specific directions to have piezoelectric effect. आपको उसको x axis या y axis किसी particular direction में उसको cut करना पड़ता है, then only you will be able to observe the piezoelectric effect. So the cutting and the shaping of this quartz crystal is a very complex process because this is a very fragile crystal. So these are the disadvantages of using quartz crystal for magnetostriction oscillator or for piezoelectric oscillator, or in general disadvantages of the piezoelectric oscillator. Now we'll move on to the next oscillator, magnetostriction oscillator. Before we do that, there is something called as magnetostriction effect. This effect is basically shown by ferromagnetic materials only. Such as iron, nickel, cobalt. What happens if you place these ferromagnetic materials in a magnetic field? Let's say this is the North Pole and this is the South Pole. So there is a change in the dimension of the road here. If you place any ferromagnetic material in a magnetic field, there will be change in the dimensions of that ferromagnetic material basically. Now, there are a couple of things here. This change in dimension. Here I have shown extension depending on the material. For example, maybe iron will show extension or expansion, nickel will show compression. It's not necessary every time there will be expansion only. There might be the cases where rather than being this extra length here, there might be the reduction in the length also. And here, of course, while drawing, I'm exaggerating the extension or the compression of the rod. It's very small difference actually. So this change in the dimension, it depends on the strength of the magnetic field. आपका जितना मैग्नेटिक फील्ड स्ट्रॉन्ग होगा उतना ही ये जो चेंज होगा डायमेंशन में, वेदर आपकी डायमेंशन इंक्रीज हुई है डिक्रीज हुई है, वो उतना ही ज्यादा होगा. इट डिपेंड्स ऑन द नेचर ऑफ द मटेरियल आल्सो. यहाँ पे आप आयरन प्लेस करोगे, maybe iron will show larger change in the dimension as compared to nickel or copper. So it is going to depend on the nature of the ferromagnetic material, which basically means that which ferromagnetic material you are using here. And the most important part is it does not depend on the direction of the field. Which is opposite to piezoelectric effect. Piezoelectric effect में remember we said अगर आप direction change करोगे electric field की, तो पहले अगर expand किया था तो अब वो compress करना start कर देगा. इस case में अगर let's say I did choose a material जिसकी dimension increase हुई थी, so whether your direction of magnetic field is from here to here, or if I can reverse the magnets here and if I place south pole here and the north pole here in such a way that now the direction of magnetic field is in this direction, still the material will expand if it is expanding earlier. So it is independent of the direction of magnetic field. There will be change in the dimension. जो change होंगे वो आपकी irrespective of direction of magnetic field, the change in the dimension will remain the same. And this is very much different as compared to the piezoelectric effect. जहां पे आप जैसे ही इलेक्ट्रिक फील्ड की डायरेक्शन चेंज कर रहे थे, तो पहले अगर आपका कंप्रेस कर रहा था तो अब आपका एक्सपेंड करना स्टार्ट कर देगा, और पहले अगर एक्सपेंड कर रहा था तो बाद में वो कंप्रेस करना स्टार्ट कर देगा जैसे ही आप इलेक्ट्रिक फील्ड की डायरेक्शंस चेंज करोगे. This does not happen in this case. Irrespective of the direction of the magnetic field, the material will show the same behavior. So this is magnetostriction effect. For production of ultrasonic waves in magnetostriction oscillator, magnetostriction effect is used. Here, if I'm saying that I have a material, and let's say I'm saying whose dimensions are changing if I'm placing it between two poles here, north pole and south pole. Now, rather than if using the permanent magnet, if I can use electromagnets, or if I can use a time varying magnetic field, which basically means that if I can have a magnetic field which behaves something like this. So in that case, what would happen? Let's say this is your point A, this is your point B, this is your point C, and let's say this is your point D, and this is your point E. If I talk about just one cycle of magnetic field here, what would happen? Let's say this was your originally size of the ferromagnetic material in the absence of any magnetic material, in the absence of any magnetic field. Now, once you have placed it in the magnetic field, let's say its dimension changed from AB to AC. Earlier, it was AB. When you placed it in magnetic field, its dimension became AC. That was if you have applied a constant magnetic field. Now, if you are applying a time varying magnetic field, what would happen? While going from A to B, you are continuously increasing the magnetic field, right? So what would happen? Your rod will keep on increasing in the dimension, and finally at point B, it will stop changing the dimension. And let's say at that point, again, its dimensions become equal to AC. Now from B to C, you are reducing the magnetic field from this maximum amount back to 0 here. So what would happen to your rod? It will come back to its original size, क्योंकि आपने magnetic field को 0 कर दिया है. So वो AC से reduce होती जाएगी जैसे जैसे आपका magnetic field कम होता जाएगा, और eventually वो अपने original size में चली जाएगी. When you go from C to D, I have written it capital for some reason. Nonetheless, if you go from C to D here, you have changed the direction of the magnetic field, but जो आपका maximum है, that is same as was here. Remember we said आपका जितना expansion या compression होगा, that is independent of the direction of the magnetic field. Hence, when you change the magnetic field from C to D, even though you have reversed the direction of magnetic field, your rod will again go to the same change in the dimensions. When you go from D to E, you are coming from maximum magnitude of the field back to zero. So we'll come back from AC to AB. So in one complete cycle of magnetic field, your rod goes to point C 2 times and it comes back to B also 2 times. So all we have to do right now for a magnetostriction oscillator to come up with a method to apply a time varying magnetic field in such a way that the frequency of this time varying magnetic field is greater than 20 kilohertz. क्योंकि ये फ्रीक्वेंसी जब 20 किलोहर्ट्ज से ज्यादा होगी तभी ये जो रोड है वो डायमेंशंस चेंज करेगी विद द फ्रीक्वेंसी ग्रेटर देन 20 किलोहर्ट्ज and then only the air which is around this rod will also start vibrating with the same frequency, resulting in the production of ultrasonic waves. So we have to find out a way to produce a magnetic field which is sinusoidal in nature and has frequency greater than 20 kilohertz. Inverse of magnetostriction effect is also true. Which हाँ जी
मैम एक बार बताना ये 20 किलोहर्ट्ज वाली चीज क्या थी?
Because you are interested in production of ultrasonic waves, you would like to change the dimension of this rod with the frequency greater than 20 kilohertz, which basically means that this magnetic field should have frequency. क्योंकि ये sinusoidal है, hence you can associate a frequency with it, and that frequency has to be greater than 20 kilohertz.
Yes,
आप जो टाइम वेरिंग मैग्नेटिक फील्ड अप्लाई करोगे उसकी फ्रीक्वेंसी ग्रेटर देन 20 किलोहर्ट्ज होनी चाहिए, सो दैट आपकी रोड वाइब्रेट इसी फ्रीक्वेंसी के साथ में करेगी, उसके आसपास की जो एयर है वो उसी फ्रीक्वेंसी के साथ में वाइब्रेट करेगी और आपकी जो है अल्ट्रासोनिक वेव्स हैं वो प्रोड्यूस हो जाएंगे उस केस में. इनवर्स ऑफ मैग्नेटोस्ट्रिक्शन इफेक्ट इज आल्सो ट्रू. इसका इनवर्स क्या होगा? यहाँ पे आप मैग्नेटिक फील्ड अप्लाई कर रहे थे, डायमेंशन चेंज हो रही थी. इनवर्स होगा, आप डायमेंशन चेंज करो, यू विल प्रोड्यूस अ वेरिंग मैग्नेटिक फील्ड. आप मैग्नेटिक फील्ड जो है वो प्रोड्यूस कर सकते हो अगर मैं इस फेरोमैग्नेटिक रोड की डायमेंशंस को चेंज करना स्टार्ट कर दूं. दैट वुड बी इनवर्स मैग्नेटोस्ट्रिक्शन इफेक्ट. बट मैग्नेटोस्ट्रिक्शन ऑसिलेटर इज बेस्ड ऑन मैग्नेटोस्ट्रिक्शन इफेक्ट. सो नाउ इफ वी टॉक अबाउट द मैग्नेटोस्ट्रिक्शन ऑसिलेटर, similar to the previous case, we can use an LC circuit. हम लोग एक simple LC circuit use करके we can produce the frequency greater than 20 kilohertz. How we can do that? Again, we can have, it's slightly different than the previous case. In the previous case, we use the concept of induced EMF. Now we are only bothered about time varying magnetic field. Induced EMF, we don't care about the induced EMF now. So what I can do is that I can have a variable capacitor, and parallel to it, I can have a coil, which is basically your inductor here. Now, what I can do is that I can clamp a ferromagnetic rod in such a way that this coil is basically wound around this ferromagnetic rod. Now, if we stop right now, this is your LC circuit, but this is again not an ideal LC circuit. There will be losses, there will be dissipation of energy. अगर ये ideal LC circuit होता, we could have stopped here itself. You will have a time varying current. आपके पास में एक time varying sinusoidal current होगा, whose value will be given by something like this, and you will also have a time varying charge also. And that would be cosine of omega t, right? But the problem is same as was in the case of piezoelectric oscillator. There is going to be some dissipation of energy, and we have to compensate for that energy. Otherwise, if this would have been an ideal LC circuit, यहाँ पे आपके इंडक्टर में एक टाइम वेरिंग करंट फ्लो करता, टाइम वेरिंग करंट फ्लो कर रहेगा, तो आपका क्या होगा, एक टाइम वेरिंग मैग्नेटिक फील्ड प्रोड्यूस होगा. अगर आपका एक टाइम वेरिंग मैग्नेटिक फील्ड प्रोड्यूस होगा, आई कैन choose the frequency of this current and this charge simply by again the same expression. Variable capacitor की capacitance we can choose in such a way that this frequency comes out to be greater than 20 kilohertz. अगर ये frequency greater than 20 kilohertz है, your charge is going to oscillate with the same frequency, your current is also going to oscillate with the same frequency. Hence, the associated magnetic field. Remember, time varying current produces a time varying magnetic field also. So this magnetic field will also have the frequency greater than 20 kilohertz. And now you have placed this ferromagnetic rod in a magnetic field whose frequency is greater than 20 kilohertz. आपकी रोड की dimensions change होनी start हो जाएंगी. इसके आसपास की जो air है वो उसी frequency के साथ में vibrate करनी start कर देगी. With the frequency the rod is vibrating and you can produce the ultrasonic waves here. But the same problem comes here also. This LC circuit is not an ideal circuit. We need to compensate for the losses here. And it is done in the similar way as was done the previously. Here you will have again a feedback circuit. And this is going to be now your emitter. This is base, this is collector here. And this is again an NPN transistor. So your current is going to flow in this direction. What you will do from here, you will go back and connect another coil here. Again, the same concept is used here. जब कभी भी यहाँ पे आपका टाइम वेरिंग करंट होगा, यहाँ पे आपकी इंड्यूस्ड ईएमएफ प्रोड्यूस होगी. उस induced EMF की वजह से there will be current flowing through this coil which will be fed back into this circuit over here. And your amplitude of current and charge will remain constant now. Whatever energy is being lost, that would be compensated by this feedback circuit here. So this is basic working of a magnetostriction oscillator.
Ma'am,
हाँ जी बच्चे.
ma'am, can you please explain what is the role of base emitter and collector in this feedback system? Like what the base is doing, what the emitter is doing?
So the base is basically going to decide how much current is going to flow between collector and emitter.
Okay,
right?
ma'am.
So your base is going to be deciding the flow of current between collector and emitter. जैसे ही आपका कलेक्टर करंट कम होगा, बेस करंट बढ़ जाएगा. कलेक्टर करंट कम होगा, दैट मीन्स यू आर सेइंग कि आपके एलसी सर्किट में करंट कम हो गया है. अगर आपके एलसी सर्किट में जैसे ही करंट कम होगा, यहाँ पे इंड्यूस्ड ईएमएफ में आपका इंक्रीज हो जाएगा क्योंकि आपका मैग्नेटिक फ्लक्स कम होना स्टार्ट हो जाएगा. इंड्यूस्ड ईएमएफ बढ़ेगी तो यहाँ पे करंट बढ़ जाएगा, तो आपका बेस करंट बढ़ जाएगा.
Okay, ma'am.
The frequency, again, this ferromagnetic rod also has a natural frequency, and that natural frequency is given by same formula as was for the piezoelectric crystal. Where is the modulus of elasticity of this ferromagnetic rod? Rho is the density of this ferromagnetic rod and L is the length of this rod. When this frequency becomes equal to the frequency of LC circuit, your resonance happens and you get higher intensity ultrasonic waves produced here. So this is basic working of the magnetostriction oscillator. Let me repeat that magnetostriction oscillator is based on magnetostriction effect. You need to explain the magnetostriction effect and then you need to tell the construction. You have a transistor here, you have a tank circuit here, you have a battery here. Sorry, I forgot to add a negative here. You have a battery here for providing the bias or the voltage to the transistor here, and you have a ferromagnetic rod which is clamped here. Now, if you talk about the advantages and disadvantages of this, its design is simple because remember, in the case of piezoelectric oscillator, the quartz crystal has to be cut along a specific direction, so which becomes quite complex. As compared to that, the design of magnetostriction oscillator is simple and its production cost is low. Again, because quartz was costly in the piezoelectric oscillator. You can generate high power ultrasonic waves. If you talk about the disadvantages, sorry about that. You can produce ultrasonic waves only up to 3 megahertz frequency. In the case of piezoelectric oscillator, you can produce frequency up to 500 megahertz. But in the case of magnetostriction oscillator, you can produce ultrasonic waves only up to 3 megahertz frequency. Your frequency now, temperature and humidity start to play a role here because of their effect on the iron rod. There will be losses due to hysteresis because you are putting the rod time and again into the time varying magnetic field. So there will be some hysteresis losses and there will be eddy currents also. So these are going to be the disadvantages of magnetostriction oscillator. You might have heard the humming sound near transformers जो हमारे घरों में electricity भेजते हैं. Do you know why is that humming sound produced? Anyone?
Ma'am, repeated contraction and expansion due to magnetostriction effect.
Exactly, क्योंकि हमारे घरों में जो लाइट आती है वो 50 हर्ट्ज फ्रीक्वेंसी की आती है and that is audible to us. 50 हर्ट्ज is in our audible range. आपके ट्रांसफॉर्मर में आयरन होता है, आयरन का आपका कोर होता है एंड उसमें आप टाइम वेरिंग करंट बार बार अप्लाई करा रहे हो तो उसकी डायमेंशंस चेंज होती रहती हैं एंड दैट लीड्स टू द प्रोडक्शन ऑफ हमिंग साउंड नियर द ट्रांसफॉर्मर्स. We'll stop here. We'll start from here in the next class. We'll talk about the detection of ultrasonic waves because we cannot, of course, hear them. So we have to stick to some other methods for detection of ultrasonic waves. Students have started living at a very fast race. Before you do that, there will be an extra class tomorrow at 12:10. Okay. Let me repeat that. There will be an extra class because I was on leave Monday and Tuesday. To compensate for that, there will be an extra class tomorrow at 12:10 at the same Zoom link, SPMS 5. And please do attend because I'm going to start electromagnetic waves. And if you miss the class, you won't be able to understand the coming 7-8 lectures. So please do attend the class. Class CR, please inform to the rest of the class also.
Ma'am, can you please explain why there is effect of temperature and humidity in the case of magnetostriction oscillator?
आप ferromagnetic material use कर रहे हैं.
Okay, ma'am.
Because of that.
Okay, ma'am.
Ferromagnetic materials are sensitive to temperature and humidity.
Okay, ma'am.
हाँ जी बच्चे. Again, please do attend tomorrow's class. Class CR and GRs also. आप प्लीज अपने ग्रुप में सर्कुलेट कर दीजिए कि कल 12:10 पे एक्स्ट्रा क्लास होगी ऑन SPMS 5.
मैम
हाँ जी
मैम एक चीज बताना, जैसे